Good day, everybody. In this good opportunity, I would like to present our paper entitled The 3D Simulation of Aerodynamics Performance of the Rear Wing using Airfoil Eppler 423 with Gurney Flap Edition. Fastback car is a type of a car that has a slope from the roof to the back of the car with gentle with angle about 10 degrees to 22 degrees. With this slope, the car will have the smallest wake area and also the lowest drag coefficient in this class. Unfortunately, on a fast-moving car, aerodynamic forces contribute to the increase of downforce on the front axle while decreasing on the rear axle. This condition will increase the yaw angle on the rear axle, but reducing the yaw angle of the front axle. This condition makes the car unstable and also dangerous. To overcome this condition, the installation of rear wing is able to increase the downforce of the rear axle and then reduce the yaw angle on the rear tire. In this case, it will improve the stability of the car. For the types of airfoil for the rear wing, previous research, we studied the previous research of 5 airfoil types. There are GH10, E423, FX74, LA5055, and S1210. It showed that the CH10, E423, and FX74 and also S1210 have high negative lift coefficient at angles of attack from 3 degrees to 12 degrees, as it shows shown in the figure A. Figure B shows that the S1210 airfoil has the best efficiency, followed by the FX73 and the E423. But unfortunately, the S1210 airfoil has a geometric shape that is difficult to be manufactured due to the thin trailing edge. The rear wing performance can be improved by adding the Gurney flap on the trailing edge of the rear wing. This Gurney flap is able to increase the downforce of the rear wing with only a small aerodynamic disturbance. In the study, E423 was selected and also the Gurney flap is added to increase the lift coefficient of the airfoil. Our research objective is to determine the flow pattern and the velocity and pressure distribution on the rear wing that has Eppler 423 airfoil with the Gurney flap attached. The 3D simulation is done by using ANSYS Fluent software, which could provide accurate results and with ease of use. To simulate our model, we simplify the fastback car into the Ahmed body. In this study, we use Ahmed body that has 15 degrees rear slant angle to follow the geometry of the fastback car. After validation of the Ahmed geometry model, then we add the rear wing on the Ahmed body. The design of rear wing has two end plates, and then we compared between the rear wing without Gurney flap and to the rear wing with Gurney flap. The angle of attack of the model would be 0 degrees, 7.5 degrees, and 15 degrees. This is the meshing of our model. We use face sizing and body influence on the model to get the best quality of the mesh. This is the result, the flow pattern around the rear wing. We compare on the left side is the flow pattern of rear wing without Gurney flap, and the right side is flow pattern with Gurney flap. Yeah. Yeah. The rear wing with the Gurney flap shows that it can delay or cancel spiration from the flow spiration from the surface of the bottom surface of the rear wing. It can be seen very clear on the rear wing with the angle of attack of 15 degrees. On the left side, there is a spiration starting from almost from the middle of the airfoil on the bottom surface. But if we see on the right side, the rear wing with the Gurney flap, yeah, you can see that there is no spiration on the bottom side of the rear wing. The velocity counter confirms the result of the streamline of the flow counter. If we see the rear wing with a 7.5 degrees angle of attack, you can see that on the left side, the rear wing without Gurney flap, there is a spiration, flow spiration on the bottom surface of the rear wing. And then increase the flow spiration moving forward or to the leading edge of the rear wing. As you can see in the 15 degrees angle of attack. But in the case of the rear wing with the addition of Gurney flap, there is only very small flow spiration near the trailing edge of the rear wing. In the pressure counter, it looks very similar, so we cannot uh, see the difference between the rear wing with the Gurney flap and the rear wing with the Gurney flap. So, as the conclusion, from the result, we find that the application of Gurney flap on the rear wing is able to change the streamline flow around the wing, and also that the 2% chord height of Gurney flap is able to cancel the spiration on the rear wing, thus increase the downforce to the rear wing. The study also found that the addition of rear wing with Eppler 423 airfoil and Gurney flap attached has better performance than the rear wing without the Gurney flap. That's all our presentation. Thank you very much for your kind attention. Goodbye.